Okay, year 12 further. So what I'm going to do is I'm going to just go through 3 examples of expressing impartial fractions. It's quite an easy technique, really, so it shouldn't be too much of a bother for you. What I would suggest you do is watch the first one, and then for the second 2, have a go at them first, and then see how you cope with doing them. So basically pause the video as you would have done on Maths Watch. So the basic idea is we take our fraction, which looks like this, and we're going to say that is going to be equal to a over x plus b over 2x plus 1. I'm not going through too much of the sort of theory or where these ideas come from, because you'll get that in your normal maths lessons, but you need to be able to do it now in further. Okay, so having done that, I'm now going to multiply through by this whole denominator. So that means on the left hand side we're just going to have 5x minus 1. On the right hand side, when I multiply through by this, these x's will cancel here, so I'll just have a multiplied by 2x plus 1. For this one, the 2x plus 1's will cancel, so I'll just have b multiplied by x. Okay, so now we need to, these are identically equal, so they're true for any particular value of x. So I'm going to choose just some values of x which will help matters. The most obvious one to choose is x equals 0, because that will get rid of the b here. And so I put x equals 0 in here. Obviously on the left hand side I'm going to have minus 1, and over here I'm going to have, well, that's going to be 0, so minus 1 will be equal to a. So that's pretty nice. To get rid of this, I need to put x is equal to minus a half. That's going to be a bit more of a pain. So the a bit will disappear, so obviously I'm going to have minus a half times by b on this right hand side. This one, 5 times minus a half is minus 2.5, so that's going to give us a minus 7 over 2. We could then just multiply through by the 2's, so minus 7 is equal to minus b, and so b will be equal to 7. So therefore our whole thing must be equal to minus 1 over x plus 7 over 2x plus 1. And that's going to be dead useful for method of differences, because obviously you've got one thing that is negative. So if you were summing a series, as you will be doing on the exercise, you can just use method differences. Okay, so in Maths Watch style, you may want to pause it now. Okay, right, okay, so if you didn't pause it, you probably noticed that you could have factorized this to start with. So we're going to do that. That's going to factorize to x plus 1. And now we're going to say, right, that's going to be equal to a over x plus b over x plus 1. We can now multiply through by the x plus 1. So that's going to give us 4 is going to be identically equal to a times by x plus 1 plus b multiplied by x. We're now going to let x equal to 0, which will give us 4 is equal to a. So that's great. And we can then let x equal minus 1, which will give us 4. So minus 1, this bracket will disappear now, so 4 is equal to minus b, and so b is equal to minus 4. So that means then that our whole thing must be equal to a, which is 4 over x, minus b, which is minus 4 over x plus 1. And again, as you can see, this will be dead useful for method of differences. Okay, so that's that one. Here's question 3. So again, in Maths Watch style, have a little look at this, see what you can do. So pause it now. Okay, you've unpaused it, so let's have a little look. We'll start off with factorizing this. So this would be 2x plus 1 over x plus 3. We can now say, okay, so our 2x plus 1 over x plus 3 must be identically equal to a over x plus b over x plus 3. We can now multiply through by this denominator, giving us 2x plus 1 is identically equal to a times by x plus 3 plus b times by x. Okay, so to make matters easier, we're going to set x is equal to 0. This gives us 1 is equal to 3a, and so a must be equal to 1/3, and we're going to set x is equal to -3, giving us 2 times -3 is -6 plus 1 minus 5 is equal to, that will disappear, -5 is equal to -3b, and so b must be equal to 5/3. So a little bit of a unpleasant answer to this one. You're going to have 1/3x plus 5/3x plus 3. And there we go, that is partial fractions for the purposes that we need it right now.